Hi, good morning, and thank you for joining us today at Quantum Korea. My name is Rizwan Hussain, and I am the IBM Quantum Leader for Asia Pacific and Japan. What I'd like to do over the next 15 minutes or so is talk to you about how we are working with our clients and partners to help them move towards quantum advantage in the near term by 2026, and then move them towards what we call fault-tolerant quantum computing in the longer term. About 10 days or so ago, IBM made a major announcement. We basically called out that we will deliver a large-scale fault-tolerant quantum computing system by 2029. So as I go through my presentation, I will talk a little bit about how we're going to get there and how we're going to deliver on our roadmap and the promise and the commitment that we've made to the industry. Let's start talking about the IBM Quantum Mission. So the IBM Quantum Mission is really to bring useful quantum computing to the world. The most important word in that entire statement is useful. So what do we mean by useful quantum computing? By useful, we're talking about being able to really advance fundamental research in areas such as high-energy physics, chemistry, materials, mathematics, and more. We're also talking about building the quantum workforce of the future, and we're also talking about exploring applications and use cases across different industries that can be tackled using quantum computing systems. Now, in order to be able to bring this useful quantum computing to the world, there are two prerequisites that we're really focused on, two key areas that we're really building out to be able to deliver useful quantum computing. The first is all about technological innovation, and that's about developing a quantum platform that scales beyond classical computation. What do we mean by that? We mean building really the best-in-class hardware, software, and middleware capabilities. The second component of that is all around business collaboration. And this is about activating and really building out an ecosystem of partnerships with academic institutions, with research labs, and with enterprises across many different industries to really advance the work around algorithm development and algorithm discovery. So really, when we think about useful quantum computing, we're focused on the technological innovation, but then also building out the business collaboration to make quantum useful to our clients and partners. Now, IBM has been on this quantum computing journey for about 18 to 20 years. And as we think about our journey, there are three fundamental milestones that we've been really focused on. The first is all around establishing and demonstrating quantum utility, and that's something that we achieved about 2 years ago in 2023. What is quantum utility? Quantum utility is this whole notion that you can build a quantum system that can run circuits that cannot be run on classical computers. And this is a piece of work, a collaboration that we did with University of California, Berkeley, on a chemistry project, and this was published in the Nature publication in 2023. So that was the first substantiation and the first big milestone that we hit 2 years ago. The second big milestone that we're focused on now is something that is really near term for us. That's by 2026, we are committed to demonstrating quantum advantage. What is quantum advantage? There's a lot of people in the industry that are talking about quantum advantage. For us, it's building a quantum computing system that can do things faster, cheaper, more accurately than classical systems. And where we see the first couple of applications from a quantum advantage perspective are in chemistry and material science. And then from there, we move towards 2029, and this is the big announcement that IBM made, that we will, by 2029, deliver the first large-scale fault-tolerant quantum computer by 2029. So what is that? That's really taking quantum advantage and exponentiating it over the next 4 years. And that's where we're going to be able to solve and tackle some of the more complex problems outside of chemistry and materials. So in areas such as optimization, machine learning, partial differential equations, and so on and so forth. So again, the roadmap that we're on really established quantum utility, which we did by 2023, moving towards quantum advantage next year, and then fault-tolerant quantum computing by 2029. Let me walk you a little bit through the roadmap that we have. And this is a roadmap that we have. We can share with you in a lot more detail. We've got a booth out there. We can certainly walk you through that in a lot more detail if you'd like to come by. But really, our roadmap is really the IBM Holy Grail. Right? This is something that we look at as being able to assess how far we've come in our quantum journey, but then it also gives highlights and visibility into where we are going into the future. When you think about our roadmap, again, the biggest announcement that we've made is that we will introduce Starling, which would be the processor that we will use for our fault-tolerant quantum computing system by 2029. Three fundamental areas that IBM is focused on to move towards fault-tolerant quantum computing. The first is building modularity, so we can scale up both in qubits as well as in the number of gates to move towards quantum advantage in fault-tolerant quantum computing. That's the first area. The second is really the communication, the connection between our quantum systems. And the third is all around middleware. So if you really look at our roadmap, the first couple of layers are all around applications and algorithms. That's where building our IBM software toolkit, our middleware, our circuit libraries, our Qiskit functions to really enable developers, researchers to further their work from an algorithm development perspective. The second layer is all around orchestration. And orchestration is our fundamental belief that quantum will not exist in a silo on its own, but really needs to be integrated with high-performance computing systems. So there's a lot of work that IBM is doing, and we've coined a term called quantum-centric supercomputing, which is all around that middle layer that we call orchestration. And then the third layer, which you see in black, is our hardware and our platform development roadmap. And so if you really look at the roadmap, we had the Heron processor. It has 5,000 gates, 133 qubits that we launched last year in 2024. This year, we are very, very excited to introduce Nighthawk, an announcement that we're looking to make towards the end of the year. Nighthawk is game-changing from our perspective. Why is it game-changing? Because it's going to be able to connect 120 qubits on a square lattice. And this added connectivity is what's going to allow us to do more with the same gate fidelity. From there on, we're going to be able to scale up in terms of the number of gates. We'll go to 7,500 gates, 10,000 gates by 2027, and then 15,000 gates by 2028. While we do that, we also increase the scalability in the number of qubits, going to 360 qubits, over 1,000 qubits, and then 120 times 9, another 1,080 qubits by 2028. All of that, in combination with the work that we're doing internally from an innovation roadmap perspective and the work that we're doing around error correction, is what will allow us to introduce Starling, which would be the processor that we'll use for our fault-tolerant quantum computing system by 2029. So again, if you need to learn more about our roadmap, we are committed to this. We have made a major announcement. We've had the ability to really deliver on each of the milestones that we've laid out from 2020 onwards, and we're fully committed to delivering this as we look towards 2029. Changing gears a little bit. So IBM was one of the first companies to put our quantum computing systems on the cloud. We did that in 2016, and since then, a lot has happened. We now have the largest quantum ecosystem in the world. We have over 280 plus clients and partners. We have about 55 or so industry members. Industry members are clients that we're working with across different industries: financial services, healthcare and life sciences, aerospace, automotive, high tech, and so on and so forth. We're also building a very robust startup community. And the reason we're partnering with startups is because we want these startups to be able to build out their hardware and software offerings using IBM quantum technology. And then lastly, we're certainly building out our relationships with academic institutions and research labs. And the reason we're doing that is because we really want to work with them to advance fundamental research in some of the areas that I mentioned earlier, but then also to help develop the quantum workforce of the future. Now, as we look at research in quantum computing, we feel that there has been a big proliferation in research and papers and publications that are coming out there, and IBM has been one of the major contributors to the proliferation in research. If you look at some of the data points that we have, we pulled together a report of the documents that we have on the archives in quantum physics category. About 3,800 or more papers and publications have been published either by IBM researchers or through partners in our ecosystem using IBM quantum technology or using Qiskit, which is the software development toolkit that we use. Is that a big number? That actually represents about 45% of all the papers and publications that are out there. So we actually feel we're making a massive contribution towards driving innovation from a research perspective. And this is one of the strategic priorities that the IBM quantum team has to really drive more and more research through the work that we're putting out there. Now, one of the other areas that we spoke about earlier is really to build out the quantum workforce and really build out the skill sets that are needed to deliver on some of these quantum projects. So we're collaborating effectively with all of the 280 plus partners that we have in our ecosystem. Some of the key projects that we're working on, we have a Road to Practitioner program that we've opened up to our key strategic partners. And there are about 437 or so practitioners that have gone through the Road to Practitioner program at this point in time. We also, for the last 4 or 5 years, have been running a summer school. We call it the Qiskit Summer School. And just last year, we had the largest enrollment ever, 20,000 students that were enrolled and went through the Qiskit Summer School that IBM offers every summer. We have one that's going to launch this year as well in July. So if that's something that you're interested in, we can certainly open that up to you as well. We're also working very, very proactively with some of the industry partners. There's 50 plus prototypes, road to utility projects across many, many different use cases and across different industries that we're working on with some of our key clients and partners. And then the last concept that we're very unique in terms of something that we brought to the industry is this whole idea of technical working groups. These are collaborations that we have set up across 5 major areas. And the idea is to bring together subject matter experts from quantum world, from classical world, from academia, from industry, from research, bring the best of those minds together to really start looking at what are the application areas, what are the use cases that could be tackled in these 5 strategic areas over the next 3 to 5 years. The technical working groups that we've created and facilitated are in high energy physics, material science, sustainability, optimization, and healthcare and life sciences. And then as I try and wrap up here, I want to give you a sense of the impact that we feel can be created across different industries. Some of the key industries that we're seeing use cases and applications in are certainly financial services, both on the banking as well as on the insurance side, healthcare and life sciences, aerospace, automotive, chemicals, high-tech, and certainly the energy and utilities industry as well. And then purely from an application perspective, there are 4 main application areas where we feel use cases will be explored. What we see as the nearest term is around chemistry and materials. When we talk about quantum advantage by 2026, we're thinking of chemistry and materials as that area where quantum advantage will be demonstrated. And then from there, in the 2 to 4, 5 year time frame, we expect to see more use cases around optimization and search, followed by machine learning, and then we certainly see linear algebra and partial differential equations in the longer term as we move towards fault-tolerant quantum computing. So with that, I want to thank you for your time, and we do have a booth right in front of you, so if you get a chance, please do come by. We'd welcome you. We'd happy to engage with you in a discussion, talk to you a little bit about our technology roadmap, and then certainly open to a business collaboration partnership with you if that is of interest. Thank you for your time.